Hello, ladies and gentlemen. Welcome to my presentation about engineering to order and critical chain. And first, I will start introducing myself. My name is Etienne Le Serre. I'm French, based in Paris. I have worked with Philip Morris over the last 7 years as a consultant, and I work both in production and project environments, mostly for industrial companies. And I have used the critical chain approach in different environments like engineering to order, of course, but also maintenance, repair, and overall CapEx projects, new product development, and others. So today I wanted to talk about my lessons learned and the things I learned working with different companies in engineering to order environments. I will share a bit of theory and a lot of practice and a few tips and tricks to help you improve the performance of engineering to order companies. Engineering to order companies are different. So let's discuss the main problems we see in such organizations. I'm sure that you are able to think about many examples of engineering to order companies. They are the companies which manufacture products such as special machinery, machine tools, special pumps, turbines, power transmission systems, ventilation systems, paper mills, well, whatever products which require to meet very specific customers' requirements. And so this means that these industrial organizations have to handle to deal with the full process, engineering, manufacturing, procurement, assembly, before being able to ship their products to their customers. As a result, we can consider that each and every order managed by these companies is like a project, hence critical chain. And as a customer of these engineering to order companies, if you have to wait for engineering, manufacturing, and assembly, well, you bet that you will prefer a company which is able to deliver quicker than competitors and which is reliable. So speed in these environments and also reliability, so the ability to deliver on time, are key competitive advantages. And it's difficult in these environments to be reliable and to be faster than competitors. Plus, if you are late, you may have to pay penalties, so the cost of delays can be very high in these environments. And as I said, you have to manage the full process. So if you're chief operating officer or project manager or project management, working for the project management office, you have to deal with engineering, methods, manufacturing, assembly, procurement, well, many different activities with quite a lot of uncertainty involved in each of these operations because you are working with non-standard products. So you are working with non-standard products, and what we have seen in these environments, and which this always strikes me, but the level of work in process in these environments is usually very high. So when you visit for the first time the engineering department, for example, and you start counting all the items which are ongoing, you soon realize that there is too much to handle. And it is as if there were no cost of initiating new work. But in the end, and we will talk about it, the multitasking generated by this high level of working process is damaging the performance of the whole organization. What we often see is that people, for example, the technicians and the engineers working on the first phases of the projects, they keep switching from one task to the other and bouncing between projects. So this is what I wanted to illustrate. And some managers in these environments may think that WIP, work in process, can be used as a whip to, let's say, motivate the workforce. But on the contrary, when you have too much to handle, too much on your desk, you multitask and lose a huge amount of time. Let's talk about it. There is another phenomenon which is aggravating the, well, the huge load on the desk of the engineers and technicians in engineering to other environments. And I don't want to do finger pointing, but what I've seen usually is that the sales department is not helping because they keep pushing new jobs, new projects in the engineering and methods department, but without providing full kits of information, complete specifications, complete documents, making it easier to start working on the projects and make sure that when you start something, you are able to finish it. Moreover, sometimes what we've seen is that the sales department continues to sell new features or additional stuff to the clients, and so this generates rework in the engineering departments. And also what I've seen is the sales department going to the engineering departments, asking questions, disturbing the technicians, and forcing them to multitask again. So this is just a warning. It's not finger pointing, but raising awareness of how departments actually collaborate and, well, the damages that bad behaviors can also infer, can also generate. So as I said, in the offices, what we see is that the people are multitasking badly. They keep bouncing from one task to another, but what is very often neglected in companies is the effects of multitasking. People will say, well, it's normal. You have to be able to juggle between tasks. You have to be able to prioritize and to manage your own work. Yes, okay, but do not neglect the fact that every time you switch from one activity to the other, you lose focus and you have to reconcentrate. You have to refocus on a new task. And then you forgot what you were doing before and you have to reopen the documents, you have to look back at what you were doing, and you lose a lot of time. And if you keep working like this, well, in the end of the day, you've not done everything you were supposed to do. So it's hurting, it's damaging the efficiency of these departments, and it's even worse than what you could think. I also have seen that in many engineering to other companies, the work is split in many tasks, but nothing is done in a row. So they start the pre-design of the machine, then they wait for the client to answer, then they work on the gears, and they wait a few weeks and work on, I don't know, accessories, and then wait a few weeks and work on the last part of the design, for example. So the lead time of the design phase is very long, and because they have so much on their plate, so much to do at the same time, what they do is that they prioritize depending on the lead times of procurement. But another solution, and we will discuss it, would be to decide to do everything in a row to make sure that you get the complete bills of materials as soon as possible, instead of always waiting for the bills of material to be complete until the end of the project sometimes. And in these environments, there is another common topic, the rework. So people keep reworking or redoing things. The common reason is that the client has changed his mind. But in my eyes, it's not the sole reason. There are others, such as the fact that full kits were not available when they started working. So they do not have the complete information and they have to make assumptions, which are wrong sometimes. So you have to rework. Also, the projects are too long. So if the projects take too long, too much time, then the client has more time to change his mind. And another reason is that sometimes the sales department continues selling new features because there is no design freeze. So if you sell something new in the middle of the project, you have to adapt what you designed and to rework. And I have talked a lot about engineering, the engineering department in engineering to other companies. But as I said, there is also manufacturing and assembly as well as procurement. And what we've seen is that in engineering to other companies, the shop floor is, well, looking at local optima instead of the global optimum. They manufacture the parts in order to make the machines more efficient, and so they try to reduce the changeovers. The problem is that they mix the manufacturing of the parts which are required to assemble different products. And in my example, what I'm showing on the slide, in the upper part of the slide, it's just an example of how you would cut plates. So imagine that you have 3 products with plates to be cut, 3 plates per product with different thicknesses. Well, what will happen usually is that the machines, they will group the plates with the same thickness, even if they are required for different products. So it takes a long time before getting all the parts to assemble the product. So what we push usually is instead to manufacture the parts, but to get a full kit of parts for assembly as soon as possible, even if it means more changeovers. So, to help these companies, we use the critical chain framework. Let's talk about it. If you attend this conference, I'm sure you're familiar with the TOC 5 focusing steps. Well, this is usually what we start with. First, we identify the bottleneck, and the usual suspect is the engineering department. Then we exploit the constraint, and I will talk about a few tips here to increase the capacity of the bottleneck. Then we subordinate everything else to the constraint. So this means that we usually stagger projects to, well, level the load and decrease the working process to favor focus. And then if it's necessary, we can invest a bit more, hiring people, buying machines, or etc. And then, well, you have new bottlenecks and you keep going. Okay, then you will ask me, but how do you know where the bottleneck is? What I generally do is count the number of projects in the organization and check where they are. Are they waiting for engineering, for the methods department, the factory, the procurement, or assembly? And chasing the biggest queues help you to understand where the bottleneck is. The bottleneck is where the biggest queue is. And once you have identified your bottleneck, there is an exercise that I like to do, to perform, which is the day in the life of. So I will usually sit next to someone, a technician or an engineer working in the engineering or methods department, if these are the bottlenecks, and check the tasks he's working on and how long it takes. And then at the end of the day, we can categorize the activities and see if it is value added or not, if it's about meeting, administration, asking questions or answering questions, this kind of thing. And more importantly, we can count the number of activities he worked on in the day and how much time was dedicated to each task. So this is a great way to assess the level of multitasking and then get buy-in of management to show that really there's a problem and that the current situation does not help people to work properly. So if you want to distress the organization to be able to deliver more, you have to reduce the level of work in process again. And to do so, you flush, you freeze, and you frame this reduction of work in process. So you flush because, well, let's do it like this. You try to finish all the projects that are almost terminated, focusing your resources on these few projects. Then it's over and you can work on something else. Freeze. Choose some projects which are less important than others and freeze them. Nobody should touch these frozen projects. And then and you should freeze like 15 or 20% or even more of your projects. Then you have the remaining projects, and to reduce the number of projects until it's acceptable, you can use the 2-for-1 rule. The 2-for-1 rule, is very simple. Every time 2 projects go out, you are allowed to accept 1 new project, to start working on 1 new project. So 2 out, 1 in, until the load is acceptable. And once you have reduced the number of ongoing projects, and I did not mention it, but you should definitely do it with the salesperson. They are the ones able to tell you the priorities. So once you've done it, you can plan better the remaining projects to accelerate them, to then be able to unfreeze the projects that you had frozen. You will use the critical chain project management approach to plan these projects. The difference with other approaches is that, well, you list the tasks, but you give ambitious estimates. You do not want margins in the duration estimates of the tasks. But on the other hand, you will add a substantial buffer, additional time at the end of the project, a buffer, and you will monitor the consumption of this buffer. I will explain it later on. You also want to model the resources to take into account the load, because you do not want to plan multitasking. You want to plan a project so that resources, people, machines will be able to focus on the tasks, focus on it, so once it started, they will be able to finish it. They won't have to wait for their colleagues, for management experts. You want really the organization to be able to go as fast as possible on the task you've defined. And this requires to take into account the availability of resources. And usually the first picture of the project is not as satisfying as you'd like. So you will have to optimize the first draft of the plan and work on it. So organize workshops to discuss how to reduce the critical chain. So as I said, what you want to do is to enable the teams to focus, in particular in the engineering and methods department. So when you define the schedule of the project, you have to think in terms of work packages. What are the groups of tasks that you want to be bound and to be done together? And think about who is required to perform these tasks. Not only, for example, the technicians, but also the managers, the experts. And you want to limit the working process. So do not plan too many of these work packages at the same time. If they require the same resources, level the load and focus on one work package, then start the other one. You will see that you will drastically accelerate the work packages doing like this. In manufacturing and assembly, it's different because we're not talking about office work, but still you can use also visual management to show what groups of parts must be worked on, in particular in manufacturing. And in assembly, you can also use detailed schedules to show the steps. So the critical chain can be very useful also in the assembly department when you have to assemble complex machines. If you really want to handle the details in the offices, in the engineering and methods department, I definitely recommend using Kanban boards to visualize the small tasks and make sure that people know what they have to do in the morning when they arrive at the office. What you want is a simple tool to compare the projects and also to know when to expedite it and to know if you will finish on time or not. Assess the situation. So we use the fever chart when we work the critical chain way, and on the left hand side of the screen you can see a fever chart for just one project. On the horizontal axis you have the progress, so how much time is remaining on the critical chain compared to the initial planned duration of the critical chain. And on the vertical axis you have the buffer consumption. So how much of your buffer have you consumed? If you're in the green zone, it means that you are not consuming your buffer too fast. It's okay. You are likely to finish on time. But if you start running in the yellow and then red zone, you should be careful. Take care. If the project continues like this, it will be late. React. Find countermeasures to accelerate the remaining tasks on the critical chain. On the right-hand side of the screen, you can see the same tool, the fever chart, but for a portfolio of projects. It is very helpful to compare the situation of different projects. And then you can understand what projects you should focus on. So if it's in the red zone, the project is going to be late. But in the green zone, it's okay. So focus your resources on P1 and P2 and P4, not on P11 or P7. And because I don't want to be too theoretical, I wanted to present some of my experiences. I have worked with an oil and gas company manufacturing power transmission systems, power transmission gears plugged between a turbine and a generator on oil rigs. And with my colleagues, what we found was that they had up to 90 projects to work on at the same time in the engineering department. And only 1.8 designs were finished per week. So the throughput was not enough to satisfy the demands, and the lead times had been increasing a lot over the last months. And now they were taking up to 50 weeks to complete the design of a product. The documentation was sent to the customers even after the product was shipped to the customer. So the priorities were switching, were changing, people were complaining, were tired, and the situation definitely had to be improved. As I explained, we started by reducing the work in process. So we applied the 2-for-1 rule hand in hand with the engineering department and the sales department and top management. So we had to prioritize the projects, freeze some of them, focus on finishing the almost terminated projects, and stop initiating new projects, or at least initiate one new project only once 2 projects have been terminated to reduce the queues and enable the teams to focus on a limited number of topics. We of course worked with them to plan the projects the critical chain way. 2 project coordinators were named, and their role was to centralize all the demands instead of disturbing directly the technicians, sending them emails, questions, calling them, etc. So really what we wanted is to protect the technicians and engineers to enable them to focus on their daily job. And also we had the buffers and the fever charts to monitor the progress of the projects and prioritize them accordingly. So the main ideas was to protect the technicians and to change the way, the process of designing the machines. The tasks were grouped and the full design was done in a row to get the full bill of material as soon as possible, instead of splitting it in different subset of work and with waiting times between these parts of the design. And when you do that, when you group the tasks, when you do everything in a row, when you focus on full kits, and when you reduce the work in process, the resources, they accelerate tremendously. And they passed from 90 ongoing designs to only 41, and then even down to 30. So they could focus on a more limited number of things and do this much faster. So they started with 1.8 design performed per week and increased the throughput to 4.2 designs terminated per week. So a huge, huge increase. But you can also use everything that I have said in the luxury good industry if the products are customized. And we worked with a prestigious French company which also customize the products, and more because the clients are more and more eager to get their products customized to their taste. And so the problem here was the bottleneck was a bad bottleneck. It was the persons creating the bills of materials, just putting it in the system. But the queue of work was huge, was really enormous in this part of the organization. So they started with almost 400 bills of materials or projects to handle, and just focusing more attention on this topic, they could decrease the working process and really accelerate it. So there were a few actions taken, but here my point is that you really should start with the bottleneck, find it, looking at the queues, and once you've done it, plan your projects using the critical chain method. And what you can do is track the causes of buffer consumption. So every week, when you update the schedules, you ask, why did we consume this amount of buffer? And you categorize the causes, and in a month, in 6 months, in a year, you will have a database to understand the most harmful, the worst reasons for buffer consumption and where to focus your continuous improvement. I have also worked with a company in the textile industry. They're manufacturing textile equipment, and what we found is that, well, they thought that the process of each and every project was different, but planning the projects, they realized that the process is in fact quite standard. And then once you have established a standard plan, you can fine-tune it to adapt to the specific cases. But I really encourage you to define a standard schedule during a workshop with your colleagues, for example. And also, I found that the sales department was too involved in the technical choices. I suppose it's quite common in these environments. And they really needed a design freeze to say to everybody that no, the definition of the product is done, and the design is done. Also think about the full kits. They are thinking about establishing full kits, doing checklist of what is required before starting a new project, and also a checklist of what is required before starting an assembly, for example. And that's it. And just to conclude, you see that the performance of engineering to other organizations can be drastically improved without installing complex pieces of software like PLM, like using artificial intelligence or anything like this. I don't say that you should not, but if you want to increase the throughput of the engineering department by ×2, or reduce the working process by 60–80%, or cut lead times by 2, you must focus on flow and identify the bottlenecks, synchronize activities. It's not about AI or about a PLM software. So now I will answer your questions. And by the way, if you want to contact me, don't hesitate to reach out, to send me an email. I'm sharing it on this slide, and you can also add me on LinkedIn. So let's talk.